Welcome back to Fundamental of Electrical Circuits series of videos. We're going to today talk about measured and derived SI units. In all engineering, knowing what system of units you're using and making sure that you are staying consistent with the units you have selected, it's a very, very important part of making sure you are not being led astray um, by um, that process. So today we're going to start by taking a look at the measured or based unit. Before I get started on that, though, I want to tell you that missing units, even though it's very fundamental to engineering, even very experienced, very respected organizations such as NASA and their contractors have run into issues by not being very careful with the units and systems they're using and make sure everybody knows which they're using. You may have heard a lot of stories about failed projects simply because of mismatch assumptions about what unit people are using. So we're going to, the international standards is SI units, and sometimes we also refer to as a metrics unit as opposed to English, which is commonly used in ordinary activities in the United States. So let's go ahead and start with the standards measured unit. That basically says these are arbitrarily decided, and everybody has agreed that this is how much a unit is in particular space. For example, when we start talking about length, meter is everybody has agreed meter is the length of this rod. It was a platinum rod of certain length that that resides in a museum in Paris, Louvre, and you can go there and take a look at it. That size of that rod is 1 meter. Now, why is it that long? Could it be shorter? Could it be longer? It's not a question that has any reasonable answer other than saying this is what the whole community who was involved in coming up with that standard decided it was the right size, and that's what they stayed with. And so that's what it means to be a measured unit. And then kilogram is another one. Kilogram is basically a blob of material that was certain size. So if you want to have 1 kilogram, then you need to basically have that. So the next one is time and seconds. Again, time is what we have decided, and we have devices that now measure what a second is. And again, that's, you can say that's basically an arbitrarily selected amount of time. Amp, the same way, it's measured. The measurement's a little more complex, but the idea is that there was a certain amount of electrons moving at a certain rate, was called 1 amp, based on the effect it can create in the world. Temperature, the same way, Kelvin is the standards, and that is again a predetermined number. Amount of substance or moles is another measurement, and the luminescence intensity, or which is called candle, is another measured units. As opposed to measured unit, we've got the the derived unit. Now the derived unit, once you've decided the meter is a certain size, or a kilogram is a certain size, and second is a certain amount of time, then when you, for example, start to talk about Newton as a measure of force, that no longer is arbitrary, it's based on those values. So Newton, for convenience, you can call it, instead of calling force in Newton, you can call it kilogram times meter divided by second squared, but it's a little easier to call it Newton. And that's basically what these derived units are. Derived units are a combination of measured unit that is useful in talking about a certain effect or a certain energy transfer, or energy change, or environmental change that we are looking at. In electrical engineering, we will run into frequency, which is cycles per second, commonly referred to as hertz. We run into force, which is Newton. Joules is a pretty important, joules and watt, and for us is related. If you kind of notice that joules per second or energy per second becomes a watt, another way to think about this, you can come up here and say joules is watt times second. As a matter of fact, when you get a bill from your electric company, they're gonna give you the units that you pay for in watt. Actually, they give it to you in kilowatt hour as a way of telling you what the energies that you're using. Of course, this is not strictly SI unit, but it's a little easier for people to understand what 1,000 watt hour is that they're paying for as a unit. A charge, coulomb, we'll talk more about that later. Put voltage is V, which is joule per coulomb, and then resistance, ohms, Siemens, which is 1 over ohm, or conductance. Resistance talks about how hard is it for electrons to move through a material. Conductance is the measure of how easy it is to go. Farad for capacitance, and flux for magnetic, Weber for magnetic flux, and Henry for inductance. These are some of the most common derived unit that we have. So basically we have the measured units, which are somebody picked up, some group of people decided that was the size or the amount, and then the derived are some convenient names for a combination of the measured units that are commonly accepted. And again, SI is the international most commonly used measurement in engineering and science. The other thing you may want to spend a little bit of time getting yourself familiar with in the engineering world, we end up with lots of zeros, and it's really confusing to carry a zero. For example, if you got 18 zero, it's kind of much easier to write 3 times 10 to the 18 minus 18 instead of writing 0.00 or whatever to 3 and maybe missing a 0. It's a lot easier to keep track of it this way. So these prefixes we use, instead of saying 3 times 10 to the minus 18 or do that, we might just call it 3 atto. Okay, and then it's very common for us. We have capacitors that are pico, nano, micro. We have resistors that are mega and giga. We have data storages that are peta in size, 10 to the 15 in size. So you should probably get yourself familiar with, not probably, you should get yourself familiar with these prefixes. So when somebody tells you you've got 2 gigabyte, then you understand that what they're telling you is that you have 2 times 10 to the 9 bytes. Because that is a very common way we communicate in engineering. Again, the goal for this was to emphasize and kind of review some of the basics of units we're going to use in communicating our data.